Hi, and welcome to 8.4 Trigonometry Word Problems. The moral of this story is draw a picture. Every single time you get a trigonometry word problem, if you haven't been given a picture, you definitely need to draw a picture. I find that sometimes the hardest part of these are just trying to take your word problem, your paragraph, and then draw the picture. And then once the picture is drawn, the math is actually quite straightforward. So we're going to talk about a couple of words, just some diction that we're going to find in this chapter. We're going to give them some definitions, and then we're going to do some examples. So keep in mind, whole time, draw a picture. So angle of elevation. Elevation typically means upwards. If you think of the elevation of a mountain, you're measuring how high up it is. If someone is feeling, or if you elevate something, you're bringing it up. Elated has a similar prefix, and it means to be up. So angle of elevation is a measure of an angle from a horizontal it's working on my spelling here, up. So angle of elevation, horizontal up. To go with our theme of the day, we're going to draw a little picture. So if we have a horizontal, which I'm going to draw with a blue dotted line, and then our angle would then be from the measure of a horizontal upwards. So this is an angle of elevation. And that'll come up in at least one of our word problems, so we'll get to see it in practice. Depression is the opposite of elevation. Depression means down. If someone is depressed, they're feeling down. If there's a depression in the road, there's a dip in the road that goes down. We talk about economic depression. It's when the economy goes down. So it's almost exactly the same, except down. A measure of an angle from a horizontal down. So again, if we draw a little picture, here is our horizontal line, and then it's a measure down. So this could be an angle of depression. I think I've drawn this too big, and we're going to go into angle of ascent here. Angle of depression. I might erase this line and draw it again, just so it doesn't go into my angle of ascent. So angle of ascent is a lot like angle of elevation, except it's a line that you're moving along. It's an angle of elevation that you move along. So if you were to ascend a mountain, you'd be walking up your mountain, and you could get an angle of ascent how steep that mountain would be. So you can imagine if you look at our angle of elevation diagram up here, if you walked along that angle of elevation, that would be an angle of ascent. That's the angle up that you go along. The only difference is an angle of elevation is you usually just look at it, whereas an angle of ascent, you actually move along it. Angle of descent then is then an angle of depression that you move along. In practice, these are subtly different things, but for the sake of trigonometry, you can pretty much think of them as identical synonyms. Angle of elevation is pretty much going to be the same as the angle of ascent, and angle of depression will be the same as the angle of descent. Think of them as synonyms when you're drawing the pictures. In practice, though, if you're actually talking about it in sort of the English words, if you're making a paragraph out of it, they will look, in reality, they do mean subtly different things. So let's look at a word problem. You are standing 20 meters away from a tree, and notice the angle of elevation to the top of the tree is 30 degrees. How tall is the tree? So we can draw a tree. I like a tree, maybe with a floofy top. There we go. And we are standing 20 meters away from our tree. It tells us the angle of elevation is 30 degrees. So notice how the ground is a nice horizontal, and that means that the angle from that horizontal to the top of the tree is 30 degrees. And it's asking us, how high is the height of that tree? So all I've done is I've taken that word problem and I've translated it into a diagram. I'm 20 meters away from the tree, angle of elevation is 30 degrees, and it's asking how tall is the tree. And notice how I've given the how tall is the tree a variable. So I've defined my variable, which we've done in previous word problems, on my diagram this time. We can then see that what I have drawn is a right-angled triangle. We are concerned with the side opposite my 30 degrees, and I know something about my adjacent side. Opposite and adjacent is a cosine, or sorry, a tan. So the tan of an angle is equal to opposite over adjacent. So that tan of 30 degrees is equal to opposite, which is h, over adjacent, which is 20. Multiply both sides by 20 to isolate h. And h is equal to 20 tan 30. Bring out my fancy calculator, and I can type it into my calculator. 20 times tan 30. 11.547, or 11.5 to 1 decimal, which works for me. 11.5, and this is going to be in meters. Typically, if we're dealing with word problems, we're going to have units, because units kind of help us connect the math to reality. So this will be 11.5 meters high. This is actually a very common way of measuring the height of things. People will take a digital measurement instrument and they'll measure how far away they are. You can do it with a laser or a measuring stick or a tape measure, whatever you want. And then they will measure the angle of elevation up, and you can figure out the height of things. It's actually quite common in surveying. Sitting on the top of a mountain let's try that again. Sitting at the top of a mountain that on a map is 300 meters away from a city, 3,000 meters away from the city. You notice the angle of depression to the city is 56 degrees. If you start your hike at the city, how many vertical meters did you climb? All right, so we're sitting on the top of a mountain, so let's draw our mountain. I like a nice spiky mountain. And I'm gonna, that doesn't look like snow, that looks like cloud. I think I want it, it's dirty snow. We've got some snow up top there, and here we are sitting at the top of a mountain. And then on the map, so maps measure horizontal distances. We are 3,000 meters away from our city. And for my city, I'm just going to draw, maybe I could draw a couple little houses down here. You're not allowed to laugh at my pathetic little houses, though. And it tells us that the angle of depression is 56 degrees. So angle of depression is from a horizontal, and I'll draw that dotted so it looks like the definition, from a horizontal down. So from the horizontal down, angle of depression to the city is 56 degrees. And the question is asking, how high are we? How many vertical miles did you climb? Let's call that a V for vertical. Sorry, not miles, meters. How many vertical meters did we climb? And notice how we've drawn another right angle triangle. Here's a bit of a trick, though. that 56 degrees isn't in the triangle. But if we look at this section right here, we'll see that between my horizontal and my vertical must be 90 degrees. And if I draw that separately over here, this is 56 degrees, but this has to be 90 degrees. So what plus 56 is equal to 90? And maybe I'll call this one an x. I know that x plus 56 has to equal 90 degrees. Therefore, 90 minus 56 is going to be equal to x, because I subtracted 56 from both sides. Oh, 56 from both sides, and maybe I'll do a little arrow over because that's what I'm doing over here. 90 minus 56, if you can't do it in your head, that's okay. Pull out your calculator. 90 minus 56, 34 degrees. So now we know that x is 34 degrees. And so when I go back to this, I know that this angle here is going to then be 34 degrees. Labeling my blue triangle 3000 is the opposite side. And I'm looking for an adjacent side. So I'm going to use opposite and adjacent is a tan of an angle is opposite over adjacent. So that tan of 34 is equal to 3000 divided by adjacent, which I have called V for vertical. I'm going to have to multiply both sides by V. And I end up with, and then divide both sides by tan 34, divide this side by tan 34, and I end up with V is equal to 3000 divided by tan 34. 3000 divided by tan 34, close that bracket, and that's equal to 4,447 meters. If you know hiking at all or climbing, you know that's a doozy of a day. So that was angle of elevation from a horizontal up, angle of depression from a horizontal down. Let's look at our last example. To land a plane, a pilot is instructed to have an angle of descent of 7 degrees. If the pilot is flying at 1,000 meters, and I think this is supposed to be an altitude, how far away from the airport should the descent begin? So if we're flying our airplane, and let's see if I can draw a reasonable airplane here. There's our airplane with a little window we can see out of, and maybe a wing there. I don't know if that's a very good airplane. I might have to try again. There's the wing side on it. Maybe it's got a propeller there, and there's a little cockpit with a little person in there. And then we know, is it an altitude of 1,000 meters? And the angle of descent, so from a horizontal down, is going to be 7 degrees. And we're going to end up landing at an airport. I don't really know what to draw for an airport. Maybe that's a radio tower. And we want to know how far away. So let's call that distance. So again, notice how this turns out to be a right angle triangle. So 7 degrees, we can use this trick again. I might actually move my airplane up a little bit so that it's a bit of a better triangle. Let's just do this a little bit. This is 1,000 meters. That's D, and then I can actually put my plane back where it should be. There we go. Yeah, that's a bit better. And then I can see that I'm using this 90-degree trick again. So if I was to draw just this bit, I end up with this. This is 7 degrees. 7 plus something has to equal 90. Should probably be able to do this one in your head. I think it's going to be an 83. So this angle in here is an 83 degrees. 83 degrees. And the way I did that again is a 90 plus, a 7 plus something is going to be equal to 90. Subtract 7 from both sides, which I did in my head, and I got that x is equal to an 83. Again, I'm dealing with an opposite and an adjacent, so I'm going to use tan. Tan of theta is equal to opposite over adjacent, so the tan of 83 is equal to the opposite, which is d, over the adjacent, which is 1,000. I can multiply both sides by 1,000. And I end up with d is equal to 1,000 tan 83. Pull out our calculator again. 1,000 times my tan of 83. And I get 8,144. 8,144 meters away, if he's 1,000 meters up, is when he has to start his descent. For the record, if you wanted to, because this is kind of curious, there's 1,000 meters in a kilometer, so at 8.1 kilometers away, that plane pilot is going to start his descent.
Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number one, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. And that goes along with number two. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number three to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.